All right, so one of the things we skipped over in chapter 9.1, and I kind of told the kids to do so, was skip over fermentation. I think it's best to learn it after the fact. You have to. I think you should truly understand all of respiration before we get to fermentation. And that's what we're getting to today is the process of fermentation. So ultimately, what happens is if for some reason oxygen is running low or not present, respiration shuts down. If you go back to the process of the entire process of respiration, cellular respiration, their oxygen is needed at the back end of the electron transport chain to be one of the molecules that accepts electrons. And if that oxygen is not there, those electrons won't be accepted. And this entire process shuts down. And if this entire process shuts down, ATP, or at least a vast majority of it, stops being made, and it's almost like everything comes to a halt. And that's not good. So active transport would ultimately stop, and no more ATP is made, at least in the mitochondria. So what can happen is the cell has a backup plan that is going to allow it to make some ATP to, if you will, ensure survival, at least temporarily. And that process is fermentation. And it's a backup process in most cells in which the cells will still create some ATP even if oxygen is not present. So it's an alternative to respiration. Now, some organisms rely entirely on fermentation, but those are some certain microorganisms. Complex organisms like ourselves need that massive amount of energy created in respiration. So for us, fermentation is more of a backup process, but it occurs much more regularly than you may think. So quick recap. So glucose, or glycolysis rather, if you remember, does make some ATP, and nowhere in the reaction is oxygen needed. So it takes glucose, breaks it down into pyruvic acid, creates some ATP, creates some NADH. But if you see, nowhere in here is oxygen playing a role. All right. So what's going to happen is if glycolysis is continuing, even in the absence of oxygen, it's going to continue making NADH, but it's going to run out of NAD+. All right. It's one of the ingredients, and it's going to keep churning out NADH, and all of a sudden it's going to run low on NAD+. And if you think about this as a recipe, this is a very important ingredient. And if you run out of that ingredient, your final product is never going to ultimately occur or be created. So think of it as a cake. You may have all the flour and all the eggs you need, but if you don't have any sugar, you're not going to get cake. All right, so we need to somehow resupply NADH. Now, ATP is going to be created because our cells are constantly breaking down ATP to create ATP, rather. So that's not a problem. NAD+, though, you're going to run low on that process, especially if there's no oxygen. If there is oxygen, this is one of the byproducts of the electron transport chain. So fermentation creates a supply of NAD+, so that glycolysis does not shut down. So in other words, what fermentation does is it doesn't create ATP, but it keeps glycolysis going, so glycolysis can create ATP. And basically what it does is it takes the NADH in glycolysis and turns it back into NAD+. It's as complex as it sounds. That's really all it does. All right, so to recap here, this is the process of glycolysis, taking ADP, turning it into ATP, and NAD+, turning to NADH. Now, if oxygen is there, the cell is going to go through respiration. That's a much more preferred process. It's going to create a lot more ATP. But if there's no oxygen there, now extreme cases like not breathing, but believe it or not, far safer examples we'll talk about in a few moments. But if there's no oxygen present, it's going to go through fermentation instead. All right, and basically what it does is it takes the NADH from glycolysis and turns it back into NAD+. Nowhere in here is ATP being created, but it creates NAD+, so this process can continue to create ATP. All right, and that's really our ultimate goal here. So the way you got to look at it is 2 ATP compared to 36 isn't a lot, but it's better than nothing. And especially if it's something complex like ourselves, a little bit of ATP might be just enough to keep the cell going for the few moments it is lacking oxygen until it has oxygen. So there are generally 2 types of fermentation. All right, there's alcoholic fermentation and there's lactic acid fermentation. So we're going to talk first about the alcoholic fermentation, and this is the formula for alcoholic fermentation. It takes a pyruvic acid from glycolysis and the NADH from glycolysis and creates alcohol, which, yes, is the same alcohol that is found in alcoholic beverages, creates CO2 and NAD+. This is the whole reason why fermentation occurs, is to create that. These are, you can consider waste products. So in a summary, this is what it creates. Now, this doesn't occur in us. Excuse me. This only occurs in yeast and some other microorganisms. Now, we use yeast commonly, believe it or not, to perform alcoholic fermentation. And they'll only do this in the absence of oxygen. They would much more prefer create more CO2, more ATP in respiration if they could. But if you starve them of oxygen, they will begin to perform fermentation. And we use this for, among many reasons, or in many ways, to, for instance, make bread. So basically what you do, if you mix a certain amount of yeast into dough, it suffocates, all right? And when it suffocates, it starts to go through alcoholic fermentation. And among many other things, yes, it does actually create alcohol. A small amount of alcohol is created in bread. But it does create CO2, and that's the important thing, because that's what these little bubbles are in bread. All right, it causes the bread to rise. These are little CO2 bubbles that formed when the yeast was going through alcoholic fermentation. Now, when you cook the dough, that ultimately kills the yeast. It burns off the alcohol, but it leaves behind those bubbles, which causes the bread to be fluffy and beautiful, if you don't mind me saying so. I love bread. But yes, it's also used in alcohol. All right. So, joking aside, no, I don't want to hear any jokes about kids and alcohol. But it's more complex than you believe. But in a simple sense, to make alcohol, if you mix yeast with sugary fluids, it will create alcohol. But believe it or not, it creates CO2. And back in the Prohibition days, this was a problem because people's houses were exploding, or at least their basements were, because they were, if you will, unprepared for this massive amount of air pressure. And it's more complex than this. The yeast eventually die of their own alcohol, and if not treated correctly, then this becomes quite toxic. So it's far more complex than you believe, which is why the professionals do it. But in a nutshell, they do use yeast and other microorganisms to produce alcohol products as well. So no, we as humans do not go through alcoholic fermentation. All right, we go through lactic acid fermentation, as do many other organisms. Similar process, in that you're taking pruvic acid and NADH, again, the two products of the glycolysis, but instead you're creating lactic acid and NAD+. No CO2, mind you, just these two products. This, again, is the whole reason why it occurs. It creates NAD+ and lactic acid. It can occur in our cells when they are starved of oxygen. Now, in extreme cases like drowning and stuff, sure, your cells will go through fermentation, but realistic cases would be like you're running and you haven't run in a long time, or and your muscles aren't used to supplying and circulating the oxygen in your body to that level, and your cells quickly become starved of oxygen. All right, so if you've ever done like a new sport, or you went running for the first time in a long time, you'll notice your muscles get very tired. They're not prepared. They're not prepared for this lack of oxygen. They burn off the oxygen quicker. With training, eventually your body responds and it circulates the oxygen in the blood to the correct muscles. But first time out, it can be pretty tough. Or weightlifting, for instance, you reach that point in which your muscles become starved quickly of oxygen from lifting heavy things, and then they stop working, which is why you're lifting weights. It eventually gets to the point where you can't lift something anymore. So in most cases for us, it's because of exercise or fatigue. Even, believe it or not, being awake for a long time can actually induce fermentation in cells too. And what it does for us is it creates a burning feeling in the muscles. So if you've lifting a lot of weights, you'll notice some burning afterwards. You've been running for the first time in a long time, your muscles are burning. And that's actually because of the lactic acid that's built up in your muscles that causes that burning feeling, but it will go away, all right? And again, the more you lift, the more you work out, the more you exercise, your body responds, and it circulates the blood quickly enough and efficiently enough that your cells don't have to go through fermentation, at least at that level. But your body responds. But in those early stages, yes, lactic acid fermentation is happening. But bacteria, many types of bacteria perform lactic acid fermentation, and we use them to create many things, including food products like cheese. So if you put bacteria in milk and some other cultures and such, different types of milk, different types of flavors, yada, 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 it's a somewhat complex process, and you drown the bacteria in the milk, they will actually start to create lactic acid. And lactic acid, or any other acid for that matter, in cream causes it to coagulate and solidify. And that's what cheese is. It's basically fermented bacteria milk to some degree. Side note, interesting side note. Love cheese.